Hello, this is the luckiest maths teacher in the world. Thank you for tuning into this video. By the end of it, you should be able to differentiate exponential functions using the chain rule. So the chain rule is here. We went through this in a previous lesson. We also learned in a previous video that the derivative of e to the power of x is itself, remarkably. And remember, e is a special number. It's like 2.71828. So that's what I mean when I say e. So how would we differentiate something like this? Y equals e to the power of x squared. So we have that x squared is a function and raising e to x squared is another function. We have a function of a function. So we're going to let u be the first function. We're going to let u be the thing with x's in it, what is in the power. So if u is equal to x squared, then y is just e to the power of x squared, e to the power of u. So to use the chain rule up here, du dx, so differentiating u with respect to x, would just be 2x. And differentiating y with respect to u, so remember the derivative of e to the power of u is just going to be itself. Here I've just replaced, all I've done here is just replace the x's with u's. So now I just have to substitute each of these into the chain rule here. So if this is y equals e to the power of x squared, then the derivative of y with respect to x is dy du, which is this, times by du dx, which is this. So remember, of course, u is just x squared. So it's just e to the x squared times 2x. So we have our final answer here. It took us a lot of writing to come up with that answer. So when you're doing these kind of questions, you can follow this process, but there is a quicker way to do it. Note that all we did was we left the e to the power of whatever, we just left that alone and times by the derivative of what's in the power. That is the easier way to do that. Let's look at some examples using this easier method. So let's look at differentiating each of these two functions. Let's start up here. We can use the process on the previous slide. However, the easy way to do it is just leave the e and the power alone and multiply by the derivative of what's in the power. So minus 3x, the derivative is minus 3. So that is the answer. So let's look at this one here. So you know when we're differentiating, if you've got more than one term, you differentiate term by term. So let's start by differentiating this term here. So it might look a little complicated, but we're not going to do it any differently. So what we're going to do is we're going to leave the e and the power exactly the same. We're not going to change them. So what we're going to put out the front, we're going to multiply by the derivative of the power. So the derivative of x minus x cubed is just derivative of x, derivative of minus x cubed. And we put in brackets because we're multiplying the whole thing by the e. Okay, so that's the first term. This term differentiated gives that. And of course, the derivative of x to the power of 4 is just 4x to the power of 3. And we're done. Yeah, it looks a little complicated, the derivative, but that is our final answer. So all you do is you leave the e and the power alone, and out the front, you multiply by the derivative of the power. How easy is that? All right, thanks so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.